has been a long time since I have posted. Matter of fact, as I think back, the last video was October. It's now March. So that's the duration of the winter. So bit of a time away. Have been doing a little work behind the scenes, and I'll catch you up because I have a few videos lined up here that people have been asking for. But in catching up, where have I been? We brought home a puppy back in the fall, and going through a 10-week puppy at 10 pounds to now 40 pounds, Mr. Finley, as we call him. Going through his teething and his nipping and all that has been constant watching him. So we love him, but anybody who's raised a puppy, an Australian Labradoodle, knows a bit of a handful. So now as the warmer weather is coming around, and this winter was, I'm fairly confident, was record-breaking for number of days below freezing, number of days below zero. I just didn't get out and do an awful lot. In front of me here is a video folks have been asking about for about a year. This is the 1986 Polaris Trail Boss 250 two-stroke, and what folks have been asking about is a video on the wiring harness, and I have come to understand why people want this video. In the fall, I thought I was going to take it easy this winter, and I was going to get this Trail Boss really kind of tuned up. You haven't seen it really riding in videos other than when we finished it. We haven't taken on the trails. We've had some startup inconsistencies that really made it unreliable if you're out in the woods. You're not pop starting this system. So, and I'll pivot for a moment as well. More blaster content coming for those of you that were following along on the blaster build, the built blaster in the trailer here. I do have more content on both of these coming. I have been riding, finished the break-in period on the built guy here over the winter. I have some skid plate to put on, some sprocket guard. I do actually also have an extended stem and some either fast or flex handlebars to put on. But what I want to do is I want to do a comparison of the two of these. We have the ability, we have about boy, how many miles is it? 3, 4, 5 mile loop out back we can ride that I do GPS time trials on, and I want to hammer down on that on the OEM blaster, the black and red one, followed by doing the same time trials on the built one, because it is a night and day power and riding difference. It is just absolute night and day. The OEM one with OEM suspension and metal on metal handlebars right down, everything transfers, and if I am riding full tilt out there with all my safety gear, I can't hang on longer than 20 minutes on a ride that hard. And going out with the built one, I think there's a pretty interesting comparison to be had for an endurance type ride on there. So I have more content coming there. Back to what we're working on. So this fella seemingly lost spark, and I'm going to kind of back in on here. If you understand these ones, the 85, 86, 87, and even the Cyclones, the tank, to get the tank off, you've got to take the handlebars off. Otherwise, this guy, you can't get him off any which way without lifting the bars. Bit of a pain. I've also talked about these bars, almost a straight pull from a Yamaha blaster. My understanding is that Polaris, when they first came out with this ATV, and again, this is one of the first American production line ATVs. This frame, to my knowledge, was actually a 3-wheeler frame that was modified with some additional welds by Polaris to make this first factory 4-wheel drive. Well, Polaris didn't manufacture their own top piece here. This is all metric. This is all from Yamaha, straight up blaster kind of setup, where the rest of this is from the US, is standard. So I start cranking it and I can't get it to start. Well, I can't easily check for spark with that tank on. I do not have the clearance to get in. So checking for spark, a bit of a pain, not really a fantastic design. So to find out if I had spark, take the handlebars off, take the tank off, take this on, keep myself hooked up enough to crank. When you're cranking, if you're running the oil pump, you're filling the bottom of the cylinder with oil. And if you had watched the early videos when I had 2 of these that I was combining and started getting into it, you remember just how much oil came out of the bottom of that case. I have also now run an oil injection delete. Now the oil injection was running fine, but maintaining and servicing, getting in and around it, very difficult here. Ultimately, the carb is off right now, and the only way to get in and around that oil pump was to remove the carb. Also, you see it's now, I've got these hex heads on here, bolts. It was Phillips, and trying to get a Phillips in here, you've got to get a special angle Phillip for what came from the factory. So this is from Ritter Racing. This is a delete kit. It has an insert in here to maintain the same space in your lower case for compression, so you don't actually have remove that pump and you have extra cubic inch to fill for your compression. So this will simplify, but I'll need to run premix, and I've started. First this was OEM, now I'm trying to make this a little easier for me to service and ride, just because of it's a bit of a pain to take things apart. I'm going to call another two things out here. One, if your case is filling with oil, underneath there's a drain plug. And you see that right in front of you there that's missing. And if you're cranking and you're not getting spark, you're probably filling with oil, filling with fuel. You may have to drain it. Drain it, let it air out so you're not flooding things. So if you don't know if you're fighting spark and you're cranking, it could also be flooding. Something else that came up in the over the winter here. This system does not have reeds. Carb goes straight on here. On the carb, this is the factory carb here. Notice there is no drain on this one. So if your float needle is stuck, or any of the various ways that you can end up that fuel continues to flow, even when you're turned off, it's not going to flow out of an overflow drain. You're going to notice it right away. It is going to fill up the carb and then start flowing right into the motor. And you won't notice it until it fills up the bottom of the motor, starts coming out the exhaust, and ultimately will start to drip here, or it'll fill all of this up and then drip. So on this unit, without a carb, without a drain tube within it, you've got a long time turning off to find out that you have a problem. You can shut off the fuel, remember to do that, but you wouldn't know a problem until you're riding and you find out you flood yourself out when you turn it off. So a little bit of a tough one there. So I did have to get in. Ultimately, I'm fairly confident somebody had messed with the float level earlier on, straightened that out, and cleaned up the float seal. So now we'll get that back installed. We have spark, and again, today we're going to go all the way through this wiring harness and get us back up. The other one that I wanted to mention was, I remember, throttle. Also throttle scenario here. OEM, this is interesting. I had a conversation with Rick Ritter as I was looking into this on this OEM throttle body, and I've taken the original cable away, but in some of the early videos you saw I could just pull on the cable and it would pull out. There's no safety or anything that keeps the cable from pulling out of the housing, which basically implies if you hit a tree or your hand or something and it yanks the cable, you can go wide open full throttle, just straight pull it out. That is 100% a safety consideration there. So what can I do about it? This throttle assembly, this one is original to this generation. It's actually a metal cap on it, a rarer type to my understanding. I was going to have to drill and try and retrofit here. Ultimately, what I have done is just gotten a used housing. This one, that throttle assembly is going to clip right in, can't pull it out. So I'm going to swap out to this one. And then we don't have any risk where a branch hits and just pulls this cable, pulls it right out as it used to be, and sends me wide open. Why was I swapping this cable? When I started doing the oil injection delete, it is a Y cable. One goes to the oil injection, one goes to the carb. So this was an effort to clean up all of that. And so now we're going to have this one throttle cable coming back to the top of the carburetor. The carburetor lid, there it is. Had to look, been a while since. Here's the carburetor lid. And the OEM, this doesn't thread out. I can't just swap in a new cable. I could get in here, Dremel and grind this out, and then I would have to tap this carb top, this carb lid, to function with the aftermarket cable here. And rather than do that, I just got a threaded lid. This is an easy one to pick up. This is, oh boy, I think it's the VM34. It's a Mikuni lid, threaded. This is going to go right on without modification. While I'm still looking here, here's the oil pump. This is what I removed, and it's completely 100% functional, but to get at the motor, work on the motor, you got to get the lines off. There's some various tuning. Nothing wrong with this at all. This is a preference that I'm deleting it versus running it. Also point out real quick here, this is the pump gearing. This is what was removed from the case behind the plate right behind my pinky down there, right down there, this actually sits down in the motor, and ultimately that would result in the increased area within the motor that would change your compression. So there's a filler down in there, again from Ritter Racing, thank you. So let's get into the wiring. Now, I have a manual. I always get a manual. This manual, 1985 through 1987, the two-wheel and the four-wheel and the six-wheel, the two-stroke and the four-stroke, this manual I've been very disappointed in. It is far too generic to have offered any real help. And the real piece that I needed was the electrical. And I've got all of these electrical maps, diagrams in the back. And I'm going to show you the one for this model. Here we go. So recognizing a little difficult to see on camera, but this is for the 1985 through 1988. Oh, excuse, yeah, 85 through 88. And with some study, you can easily follow this one down. This one did not. Color mapping and some of the other components that are on here did not map up to the reality of what was on this ATV. Now, I don't know if someone had been in here before me and they had put another harness on. I don't know any of that. So when you're dealing with an old ATV you're bringing back, it's hard to assume OEM. You've got to study diagrams from places like Rocky Mountain ATV to understand what did the person in there before do. Finally, I printed this one off. This one here from Google, found this in a Facebook forum, 1985, 86, 87, the Scrambler Trail Boss 4x4 wiring schematic. This one is spot on, 99%. This is the one that got me to the finish line. Why did I get myself into this problem in the first place? When I started getting into this in the fall to find out why I'd lost spark, there was a melted wire I found in the harness. It was the, if I recall, the brown white tracer here. Oh, excuse me. Into the main harness, excuse me, that's going back to CDI. In the main harness here, one of the browns, which essentially goes to ground, was melted from roughly the CDI up to the regulator. My best thought on that is that I did it to myself with a cold battery trying to start, and I threw my charger on to 65 or 75 amp starting, cranking, and just too much. And I should have warmed the battery up and kept it down to 10 or 12 amps. Bet I did that. That set off this whole hunt for no spark. And what I did, when I started checking the wiring, all of this is tucked up behind the light. I unplugged some things, figuring everything's going to go where it needs to go, and I did not take pictures. And we're going to walk through this because this has got some challenges to get it right. So I pulled the harness, I replaced the wire, put everything together, no spark. When you lose spark, there's only a couple of things to be checking. One, stator. Did your stator go bad? You can do your own resistance testing. You don't have to take everything apart. Simply unplug, put your voltmeter in here, do your tests. In this case, this yellow and red tracer is for the charging mechanism, so we don't care about that. You're basically testing resistance across these guys. You can also do a peak voltage test if you can crank. I was able to crank, so I could do peak voltage. So I had two successful readings on the stator. Peak voltage reading out and ohm resistance. So for the stator, just a couple of tests there. You have the resistance, and in this one you have an exciter coil and a pulse coil. I did print a diagram off online. The manufacturer specs for resistance, I did get those from the manual. The exciter coil, which is the brown-white tracer to white, put your voltmeter in there to measure resistance. Manual calls for 120 ohms. I got 110 ohms. That's fine. That's within that 10%, either left or right or that. Pulse coil is the black lead to the brown white again. That's looking at 23 ohm, even lower. I was getting 20. That's fine. So the resistance test, good. The other one is, some folks will call it a dynamic test. I have an RM stator peak voltage tester. If you get your hands on one of these, it's great. You can see here, I was working in the cold. It was so cold out here that the wires just cracked and snapped. So I've got to do a little bit. But this one allows me to plug in and put the probes across the stator there, then crank, and it shows what voltage is coming out. And I didn't write it down, but from memory, I was getting right about 99 volts, 98 volts coming out of that stator. Fantastic. But no spark. First, obvious big check on here. At the stator, there is a a black wire. And if you're digging around in forums, you're digging around in manuals, one of the first things they'll say to do is unplug that wire. That effectively eliminates all of the kill switch capability. If you have a failed key switch, on-off switch, anything within there that is grounding it out and killing spark, unplugging it at the stator will help cut your problem in half. That's this plug. This fella right here, coming back from the CDI, unplug this. Once you unplug this and you're cranking, you won't be able to kill spark. Throwing the switches, anything of that nature up on your bars won't do anything. That is your first test, and it's in a few different places on some other Trail Boss or Trailblazer models, but hunt that one down. The black wire back by the stator. If you've lost spark, unplug that, crank, see if you get spark. Just recognize you're not going to be able to turn things off. You know, it's a troubleshooting step because you've got the tank off anyway. You should be able to see spark. Do that one first. From there, though, what I'm just talking about, the stator test, make sure you have a good stator. You're still getting spark. If you sheared a flywheel key, you can kill spark there, but you can test if you're getting the voltage output and the ohms of resistance. I'd tell you move on to your next steps there. All right, your switches. You may have to crank these open to get an idea of the wiring. I've had difficulty with aftermarket ones where the wiring isn't quite right or just not manufactured well. But essentially, on this Trail Boss, you kill spark when those black lines, and we're going to walk through it, but when they are closed. When they're open, same way, when we unplug down that black line there, you should have spark. So if something is shorting out, that's killing. In this case, same thing. When the key is in the on position, you've closed that circuit. Forgive me on the knockoff coil. I do have an OEM one to put back in there, but this was a known good and known good boot, and everything tested out ohm resistance that I could test this as a known good. A lot of this process is getting back to known good. Testing the stator resistance, peak voltage testing, okay, it's good. Your coil, test that for your ohm resistance. You'll have specs in a manual, get them online, and you know you have a good coil. The boot, make sure the boot is on. Another obvious place to check right here where this thread's on. If these threads have come loose, take it off, clean up, peel back your coil wire a little bit, rethread on. You could be losing spark right there. Plugs, don't see it often, but make sure you have a known good plug if you can confirm on another unit. This guy here, CDI, there is no way to test the CDI to know if it is good. All you can do is work from a new CDI, or if you have another quad, plug in and test there. This is what threw me for the big loop. Ultimately, at the end of the day, punchline here, I had a bad CDI. I must have fried it at some point. I think my best guess, I put too many amps to my battery to crank and charge. That was a 65, 75 amp. Fairly certain I melted a wire there. CDI was bad. I went on eBay, bought from eBay, said known good, CDI pulled. Operating under assumption that it was known good, wasn't good. So I plugged in what I thought was a good CDI, couldn't confirm other than the listing in eBay. And having that not work and not bring spark back brought me into the wiring harness. Finally, shout out to Power Sports Nation. I bought one from Power Sports Nation that claimed to be good. It was good, and once I plugged it in, after I'd been through all my wiring, fired right up with spark. So these two guys behind me, I've put a B on because these guys are dead. The original, the one that claimed to be good. Now I have the one from Power Sports Nation. Thank you guys, appreciate that. Now let's take some time. Let's walk through this harness piece by piece because it will really help anybody that's cracking into one of these old ones. It's a little funky up under here. All right, just building into this, going to start the back and work our way forward here. BLK, black to ground, frame ground to battery. We're going to have two reds coming off of that battery. One red's going to go to a 10 amp. This is a thermal circuit breaker. The other one's going to run to our solenoid. Let's start by looking at that, and then red out of the solenoid. This is the big red one to the starter, other side of the starter, ground to frame. We can trace this leg back pretty quick, and let's do that. Here we go, back here on those reds. We were just saying from the battery into this solenoid. Out of the solenoid, this other side runs back to the starter. We can throw an ohm meter on here if we thought one of these was beat up or cracked inside. we have this red coming off of the solenoid back into the harness. And make a mental note here, a little tough to see, but it's a red with a white stripe, not a white tracer. It's kind of a diagonal, but remember that. The other red, which is coming off the battery side of the solenoid, this side, the hot side, always hot side, is going into this thermal underneath here. It's sealed, you can't get in here, but it's a thermal fuse of sorts. I haven't seen these go bad. In testing on another harness, I did cut this out and I put in a replaceable fuse harness. Tell you what, this is another harness that I had thinking I was missing something. I'm going to unwind this and show you what's behind that thermal fuse. All right, so behind this rubber boot, this is another harness, the original harness that I pulled everything off so I could get into and see it. So we'll use this as a bit of an example as well. This is what's behind that boot, thermal switch. And this one you can see had some water in it. Easy thing to do here, cut this out, replace it with an inline waterproof 10 amp, plug style, blade style fuse. You can also test this by just putting your ohm meter across here and measuring resistance, making sure it doesn't show open, but as a closed circuit. Also noting here, this solenoid shows a ground. It's grounded to frame right there by my finger. Back on our manual here, that's this guy, this little tail there, that's the ground to frame. So let's keep going. The red, with that red-white, that's that diagonal one there, is going to go to the starter. That's this one plugging in with just under my finger, that little white, tracing through the harness. That's this fella behind my finger here, into the plug that goes up to our handlebars. Top right corner, it's coming out on the top as the red-white tracer runs into our handlebar up here. And there it is. That's the red. Came in, became the red-white at that circle there. Under my finger is the plug into the starter button. Coming out of the other side of the starter button. So notice when you press the starter button, you're closing the circuit. That red is going to jump in a connector to brown, to yellow-red, and that brown is going to continue on here. So let's look at finding this. So as we just said, the red white tracer in here goes up to the starter button under my finger, turns into a, so here we are, we see brown coming out, and when I look at the other side of this plug, you see this jumper right here. So that brown on top jumps right down to the bottom. It's going to come out of that plug, but it's also going to jump into that yellow-red that we saw up top. All right, this looks good so far. We just saw that. We saw that jump going off to yellow-red. That's going to be our light switch. We don't need any of this for starting, for spark. This is going to run off to tail light. That's the blue wire. Goes out to ground. And I'll just show you, but that's this one that goes back through the harness here. A little dirty, but we'll plug in underneath down there. Not needed for start. So this whole leg goes off to lights, to headlight, to our high beam indicator on this one, which is a green-brown. Here's a blue-brown. Blue. All right, so in this case, on this unit, when we look at it, yellow is our high beam. It loops through this blue to light this light when the high beam is on, and then brown going back into the negative ground, jumping in here. So, oh, okay, yeah, there it is. It's the blue. Blue goes in, brown. So the wiring matches up with this printout. That's our high beam indicator. And yellow is our high beam. And judging from this, green is going to be our low beam. That's the other one to ground. Green coming off the light, low beam, back into the handlebar switch. So we can do our light controls up here. And ultimately, then the ground back in. Put some gloves on here. It's still below freezing. So everything is still so cold, but it means I don't have the mud. The ground is solid, but yeah. All right, starter button. We've talked about that. We started talking about this other red leg that comes down from this 10 amp thermal breaker, comes into a red, jumps. This is coming back to the key. So it's going to come all the way back. Red's going to go into the key side, come out brown, and then we also have black, black, white going to the auxiliary switch. It's the one in the handlebar. Let's walk through this. Coming out of the harness, and you see you have two reds here, but they're jumped together, so we can make the easy decision that we just got to plug these into the red coming off of the key switch, and right at my finger, that wire's cracked. Again, I was working on this outside and it was between 0 and freezing. That wire cracked. I need to deal with that. But that red goes up into the key switch when the key is in the on position and close the circuit. See, there we go. I actually have my high beam on there. When you close the circuit, it's coming back down the brown leg. That's the one under my finger here now. Brown. And that brown, what we've done, it goes into a brown-green jump. That brown goes back into the bottom of the main plug. Same area where the headlight controls, red, yellow, came in. It's all jumps, so that one's not necessarily going to matter. And then that green turns into a brown with a diagonal brown tracer going back in the main harness. Let's validate this against the paper. All right, so we can validate some of that. The red to the brown, and when we turn the key on, we did get lights. We closed the switch there. And then we started talking about coming off of that brown, which came out of the suite. It turned into a green. Yes, that green, where is that going? That's going to the reverse light switch. Green to brown, which is what we saw. And in this case, I'm going to say that's probably that brown tracer. Let's validate this piece right here. So we're starting to look at this one, this other brown next to the green that jumps off the brown on the key switch, goes back into the lower part and the upper part. I'm going to say not quite. When I say lower and upper part of this switch, it's tying back into the handlebar on off. What are we looking at? Back here, this green, and here's a brown with that diagonal brown tracer. This is coming off the transmission. This is going to be that, are we in reverse or forward? I can see multiple browns coming back into the harness. One of them is a brown, white diagonal, 2 browns, and this green runs forward. 2 other plugs here, green and brown, and to the lighting. This is not tied into anything right now. We don't need it for start. I'm going to set that off to the side for a moment here. Finishing up starting on the bottom here, let's pay attention to the auxiliary shutoff switch. Auxiliary shutoff switch, that's the big red one. So coming out of the harness, or coming out of the key switch, we're going to start here chasing it. There is going to be a black coming out one side of that key switch and a black-white. The black is going to go directly to that auxiliary shutoff switch up into the handlebar controls. The other side, black-white, it's got a jump here. It's got a plug. Coming out of that plug, more black-white, as it's calling it, to ground, to the frame. Let's see how it matches up. So this one under my finger, make sure I got a shot of it, black. This is where it starts to get funky. Well, the only pigtail you can plug into here, coming off the frame, nope, this is coming off the handlebar controls, has a pigtail that goes one way and the other way. One end goes up into the auxiliary. The other one goes back into our harness as a black here. All right, there it is. Right under the finger, there's that plug, that dot. We saw the one black goes up to the handlebars. The other one goes in, looks like it's going to jump, and it's heading out to the CDI unit. This fella right here, the other one in this jumped mess, going back in, what we've determined is that's this one here. That's everything that would kill spark coming out of CDI. Back to the black-white. Back to the black-white. Well, here we go. It's starting to get a little fascinating here. It has come out of the key switch, and it's just calling it black-white out to ground and all that. Well, we know this brown, these 3 wires here, these multi-plug, is actually grounding out to frame. And this is where it's not clear in that manual. What we've done is the black-white tracer into this ground block, also the black-white tracer coming out. Both of these are males. You can't plug them into each other. They've got to go in here. So this other side goes up to the handlebar as the manual, the printout says. This whole grouping of wires here ultimately is chasing down to become our ground. We know that from the light. We know this to close the circuit on the high beam indicator. Then it goes back into the harness here that we're going to have to chase. That is not as clear from this. That black-white going to that black plug. Black-white going off to the off position. This little dot here is that little mess of brown wires, black plug. We know it's good just from being, I guess, intelligent in this case, that it's gone to ground, etc. But that brown, in this case, it's calling it a black-white, and it's not for us. Calling it a black-white, and it's this whole mess. This guy here going back into the harness. Where does that go? That brown, white. Well, a few places here. We know it could be going back down to the transmission. Also coming out of the harness here are two more. See if I can get a good color on these. These are going up under. Yep, there we go. Those are brown. And if I look under my finger there, they ground the frame under the screws that hold the regulator in. So, okay, we can confirm that we are appropriately wired there. It calls it a black-white in this printout. It's that mess of little browns there, but it does ground out the frame. Those three little lines there ground out the frame. So our starting wiring, if we don't have bad switches, key switches, should be good. If we had the test and I thought this was bad and I don't need to be closed, I'd unplug the black-white, take an alligator clip between the two, and just bypass the switch. So first, I've confirmed so far this side. We can now naturally, if we continue through, regulator, nothing to do with starting. This is for charging the battery. Red, yellow to ground, the red coming off. We'll look at it here and you'll see I'm not even plugged in, but that's going to go to the regulator up here, the red, yellow, and ultimately it's going to run into the harness and plug in back here coming off the stator. Doesn't have to do with starting. Here is our stator representation. We just were talking about ohming out these going to the CDI to make sure the coils weren't bad in the resistance. Ignition coil, spark plug, talked about that a little bit. So we've been through lighting, CDI we touched on, stator, ignition coil. Here's our switches. In this case, this unit does not have a reverse speed limiter on it, so we're not going through any of that. So all of that going through, I still didn't have spark and had to do a third CDI, got the third CDI in. I now have spark. If I throw the switch to on, key to on, I have power coming through, and I throw it. That was my chase, chasing down, not taking pictures of that wiring harness, working off a manual that did not have the correct diagram in it, and having a bad CDI. Really had to slow down and go back to test everything through elimination, so I just wasn't throwing parts at it. Thankfully, I had some parts kicking around, like a harness. Now that we have that, we can start putting things back together. So we'll let things warm out, come out later on, keep going. But now that I can confirm spark, I can kill spark. I've got to start working through the harness, getting things plugged in, get the carb back in, get us back to a first start situation and other details. Both front tires leak, so I've got to tube those. But we're going to get this one on the trail. The warmer weather is coming. I'm excited to be out and riding again in warmer weather. Also have to finish up this guy. This is my friend's blaster. It has a massive air leak in it, and I just haven't gotten to it. I thought I was going to do a quick job here, and here we are 4, 5, 6 months later. But I'm going to pause it. I hope that walkthrough for the wiring is helpful. I know people have been asking about that, and now I'm starting to understand why, because chasing down the right diagrams, a bit of a pain. And if you haven't seen that harness and the way it's done, a little different than some of the other harnesses I've seen.